Right, yeah, this is our exam prep for tomorrow. So I do have some practice problems ready for the types of questions that are on your current homework that might show up on the exam.
Those are my questions.
Yeah, yeah, I figured that that might be coming. So we have some questions in advance for that. I'm not a huge fan of putting something on an exam before you get feedback on it, but due to the pace of the class, whenever this course is taught in the fall, it really crunches that first exam timeline. And other quarters, it makes a little bit more sense to get a little bit, half another week, which means that I can make an assignment that's due ahead of time. But here we are. So I'll just start by fielding general questions, I think, and then as there is time at the end, or if people decide that this seems more useful than the questions that I had, then we can move over to that. But if there are any general questions or concerns I can answer, if it's answered better by the practice problems, I'll just redirect to that. But what can I answer? There's something on the study guide that you don't feel so confident in, a type of problem you want to get extra practice on, something you're not 100% sure of, questions about the exam structure in general, what to expect, how to best prepare.
Are there any questions where we specifically have to do DFAs or NFAs or we
I
can
would
do either one?
I would say that as a possibility
Big possibility for me.
to be able to have to do one or the other. Can't guarantee it, but yeah, I can see myself easily writing a question like that. But the exam is written, it's just a matter of but reveal exactly what's on it, yes or no, and the answer is usually no. But both of those are valid types of questions to ask.
You have an example for converting NFAs to DFAs?
I believe so. I think that's the first thing I have.
All one up.
I have an NFA to DFA and a DFA reduction, and then some regular expressions.
Those are the two things, NFA and DFA reductions.
But anything else I can answer? Are we going straight into practice problems? I guess what I will do is I will reveal a practice problem, and then as people are working on that, you can either work on the practice problem, think of something to ask, you can interrupt the practice problem, and I'll answer your question. All right, here's an NFA. Q0 is an initial state. Q2 is the final state. Convert this into a DFA. Have we seen this kind of language representation of an NFA on your homework? So we know what we're doing, hopefully. Be able to draw that as an NFA.
Is it the new assignment we got?
Something similar might be, yeah. I don't think it exactly is. I think I pulled it from one of the bullet points that we're just on.
Say it.
If it is on there, oops, oh no, we'll have an answer for that. Tragedy.
You could just look very.
Wow, look, 3 people in here to 8 people in here.
Sorry.
Much better. I was worried that people weren't taking the review concept seriously. It's like 3 people showed up. Ah. This is better. So I've done a round of asking if anyone has questions. So if anyone has questions, just walk in since I asked that, feel free to ask them and I will answer those while people are working on this before we go over it.
Clear. If the language would be A to the I, B to the J, A to the K.
Mhm. You agree that that's what's there? So this is the first step that I would do, just because I like to think of these visually. If you're converting this into an associated DFA, I like to be able to visualize and move. When we're in this state and we make this move, what are the set of states that we could end up in? How are we doing? We have a solution yet, or are we still working? Anyone want more time? Yeah. Take a little bit more time. Sure. Anyone have any questions for me while people are working? What can I answer?
I don't think I don't recognize that notation. Is that pretty standard for how to represent an NFA?
Yeah, so this just
Okay.
represents the transitions. This is the transition starting at Q0 on an A can lead to this set of transitions. So it represents two different transitions, a transition from Q0 on an A to Q0, which is the self edge,
Mhm.
Q0 on an A to Q1, which is the edge between Q0 and Q1, etc. Allows us to combine them into the same state. It's the same line.
The only one I'm not sure about would be to go to a trap state, I think mountain trap state.
Yep.
Okay.
So looks like we might be done now. Are we good to go over? What are the set of states that this DFA could start in the NFA?
Q0.
Just Q0. So the DFA as an initial state, we'll call it Q0. From there, we need to figure out everywhere we can get on each possible character. So Q0 on an A, where could we get?
And Q0.
And Q0. Yeah, since an NFA, you can have a multi-edge out. So since that is a different set than Q0, 0 and 1 is a different set, we need a transition on an A to a new state, Q0, Q1. What happens from Q0 on a B?
This is a trap state.
Yeah, how do we refer to a trap state in a DFA that's made from an NFA? Q trap. You can do Q trap. I really like null. Or the empty set. The reason is every one of these is a set of states. So the empty set is that there is no state anywhere in here that we could get to on that. They are an equivalent idea. If you do one or the other in an exam, I don't care. Whatever makes sense as long as the structure of the graph is correct. All right, Q0, Q1, I guess the trap state's easy. Anything that is null will always go back to itself on any input character. So that's easy enough to do. But Q0, Q1 says that we are either in Q0 or Q1, or both in Q0 and Q1 at the same time. You can think of that really either way. From Q0 or Q1, what are the set of states we could reach on an A?
Itself, because if you're in Q1, then that terminates, but Q0 will then go back to the
Back
same
to
spot.
Q0 or Q1? Yes. So self edge, we get back to state 0 or state 1. You can think of being in both of these locations. This one can't go anywhere. This one can split into either here or there. So the end result of that, the set of states, is 0 and 1. So we go from 0 and 1 to 0 and 1, which is a self edge. From Q0 or Q1 on a B, where could we get? Q1 or Q2? Is this state final? Yes, nothing so far has been final. I should have asked that here. But since Q2 is final, any state that contains Q2 is final because there exists a path on AB. It's not every path, but there exists a path in the NFA to an accepting state on the edge that would get you to this in the DFA. All right, from Q1 or Q2, where can we get on an A?
On Q2.
Just Q2? Yeah, if we were in Q2, we would get back to Q2. So if we're either here or here, the Q1 can't get anywhere. So that fails. Q2 takes that edge and gets back to Q2. The set of states that is the result of that is just Q2. I'll draw that down here. That is, of course, final because it represents the same state in the NFA that is final. How about Q1, Q2 on an A? I said that on a, it's supposed to be on an A.
Yeah, Q1, Q2 on a
Q1, Q2 on a B.
it rotates on itself again because you have clone in Q1 and the one in Q2 gets replaced.
Yeah, just like before, this one can't go anywhere. This one, Q1 and Q2. So we only transition to this empty set state if the result of that is empty, not if some thread dies. All right, we need transitions out of Q2. From Q2, where can we get on an A? Back to Q2. How about on a B? Oh, nowhere. So, empty set. Here's a complete DFA. Every state has an outgoing edge on an A and a B. No duplicated edges. No lambda transitions. Nothing else of interest. This is a legal DFA. And it represents the exact same language that was accepted by that NFA. Questions on the process? Feel like you can do this on an exam? Level of confidence? Alright. Seems pretty solid, I think.
Stress doesn't get.
That's why I try to have low weight exams. Remember that they're kind of pass fail in this class. They're only worth 20% of your grade rather than the typical way more than that. As long as you average a 70% or better. Another instance of that same one. Here's a problem set for minimal DFAs. I identified B and E as being interesting and worth getting some practice on. So if you see something like find a minimal DFA, it may help you to do something like come up with a solution. And then verify that solution by going through the minimal DFA procedure.
Just a quick question.
Yeah,
Regular expressions, are they gonna be, they're gonna be on the exam tomorrow, correct?
what was on the study guide? I feel like they were. I think they were on there, but regular grammars were not.
Okay.
The next problem set is one of regular expressions. So both B and E have that typical NFA format of unions. So maybe your workflow makes even more sense if you try to make this an NFA, convert that NFA into a DFA, and then show that that DFA is minimal. That seems like a lot of work. But if you have no other path forward, that is a path forward. I think a good measure of success at this point is if you have a DFA for the first one. If you have a DFA at this point, I would say that you're intuitively on track. Yeah,
Is it 5 for the first one?
5 states?
Yeah.
I believe so. Anyone want to walk me through a DFA that they've made? So I guess first of all, anyone still working on making a DFA that they would like a little bit more time on? Couple people. This is just the DFA construction, not the minimalization proof. I know, I'm very useful.
Yep.
So first thing to note about this union is they don't share characters. We're immediately splitting on either an A or a B, and that tells us which route we're going down. Which means that this could be significantly more complicated, but it's not, which is great. Yeah,
So A goes to Q1. John A loops back to Q1.
I think that makes sense. We know we see at least one A to make this transition, and if we see more than one A, then we stay in Q1 until we finish reading the A's. Something similar for B. Go to a Q2. Loop on a B for however many of those we see. And then eventually we see the opposite character. And that opposite character has to be what ends the string. Once we're done seeing A's and we see our first B, that's the end. Once we're done seeing B's and we see our first A, that's the end. So we're going to merge these back into a new state that accepts on that opposite character. And then if we see anything past that point, we go to a trap state. Note that what's being tested here is whether you merge these two states back into Q3. You can easily see how those become two separate states. If you were designing this and saying, after A, when I see the first B, I go to an accepting state. After I see all the B's and C and A, I go to a different accepting state. If you had constructed your solution in that way, instead of merging them together, then there would be something interesting for the DFA minimization to find that two states were in fact indistinguishable. But going through that indistinguishability, we will find that this is the minimal DFA. But we should go through that process just to see it so that there is no further minimization, because this does ask you to prove that the result is minimal. So to do that, we need our half table. We have our Q. Let's do this horizontally. 0, 1, 2, 3, trap, and 1, 2, 3, trap. So these are all interesting to us. Some of these are interesting to us. Fewer and fewer of these are interesting to us. So right now, we don't know. Everything's a question mark. For this, starting with 1, we don't care. 2, we don't care up to 2. 3, we don't care up to 3. And trap, we don't care up to trap. So depending on how you draw the table, I think I've done this very differently, depending on every single time I do it, but just to see that you can set it up in a bunch of different ways. They're just rotated versions of the same table. We start by comparing finality, and we know immediately that there is distinguishability for a difference in finality. So we know that 0 and 3 are distinguishable. 1 and 3 are distinguishable. 2 and 3 are distinguishable, and 3 and trap are distinguishable. Everything else is currently a question mark. So we're going to have to go through and validate that they are in fact different. So starting with 0 and 1, what happens on an A? We get to Q1 and Q1, can't say anything interesting about that, it's the same state. On a B, we get to Q2 and Q3, which looking up in the table is distinguishable. So backtracking to the result of where we came from, 0 and 1, that is distinguishable. Between 0 and 2. On a B, we merge, but on an A, we get to Q1 and Q3, which looking it up in the table is distinguishable, so backtracking, this is distinguishable. 0 and trap on an A, 1 and trap, which we say nothing about. On a B, 2 and trap, which we also can say nothing about. So we have to leave this as we don't know. For the moment. 1 and 2 on an A goes to 1 and 3, which we look up is distinguishable. So backtracking to 1 and 2, 1 and 2 are distinguishable. 1 in trap, we can see that on a B, we're going to get 2 states of different finality. 3 in trap, if you look in the table, is distinguishable. So that means that 1 in trap are distinguishable. Same with 2 in trap. On an A, we get to 3 in trap. So those are distinguishable. All that's left now is to loop back around and test 0 in trap again. On 0 in trap, we end up in 1 in trap on an A. 1 in trap on an A now has distinguishable in it from the last iteration. So now we can go mark this as distinguishable. It just takes that second pass to be able to do that. And now we've gone through the entire table, everything is distinguishable, and that is a proof that this is a minimal DFA. All right, with that in your back pocket, let's handle the harder E problem. I would not throw E on an exam. But just knowledge of how to do it can help you to be more efficient on what does show up on the exam. Everyone have what they need from this work? Anyone still writing or copying? I think there's going to reach a point where people realize why I wouldn't throw this on an exam.
Because you have to go all the way up.
Yeah.
I had to do it for the homework.
Yeah.
I was like, this is so annoying.
Yeah,
I
yeah,
was thinking about it, I was like, no, that's the first like common number.
yeah. It is the least common multiple of them, so it makes sense that you need that. So
I keep thinking that there might be some way that I just stumble upon an answer that's simpler, but as I keep going through this, it just keeps looking more and more hopeless.
Yeah.
So you have to go all the way up to there.
there's least common
no other-
multiple.
the other stuff would be
Yeah.
so-
Correct.
Yeah, that's so annoying.
But if you recognize that, then it allows you to shortcut this entire process and have some mathematical understanding. And a second way to go prove this, rather than going through this process to prove that the DFA is minimal, you say, since the least common multiple of 2 primes is the product of those 2 numbers, then there's no way to reduce this any further. So you use a mathematical argument rather than an algorithmic argument. So that is the point that I want to make with this. I would not throw something like this on an exam that makes you say, this process that you've taught in class is annoying and complicated. Why is it annoying and complicated for this? Yes, the DFA has a lot of states, but why is it annoying for a DFA minimization proof?
So if we could say mathematically you need 15 states.
So how big is the table? How many cells are in the half table? 15 plus 14 plus 13 plus 12 plus 11 plus 10.
So
15 times 16,
Wouldn't it
over
just be
two.
easier to get 15 squared than divide by half? For like, what's in a half table, realistically?
Now it's getting its Gauss's.
yeah, it's 15 times 16 over
Yeah.
2. It's gonna be what gets you there.
Gotcha.
Yeah, 15 times 15 is what, 225? Adding another 15, 240, dividing by 2, 170 cells. Anyone want to fill in 170 cells on an exam or go
No.
through that work?
You start.
No, especially.
Yeah.
Let's catch up.
So, yeah, it's important to note that there's going to be no better way to make this second DFA than actually drawing it out and making the associated final states for that. So I could easily see throwing something like this on an exam that says find the DFA, but prove that that the DFA is minimal. That's going to be a very annoying amount of work. Considering we only have an hour for the exam, I'm not going to make you spend the entire hour on one problem. But yes, there are mathematical backdoors sometimes to these kinds of problems. The more you know about math, the more you know about the interconnectivity of ideas, the more tools you'll have. All right, we want to work on some regular expressions.
Mhm.
So here are 5 examples. Note that nowhere does it say minimal regular expression. So any regular expression that works will do.
Star mean double star inclusion.
Star, where are you seeing that? Oh, yeah. I think that's just a,
Markdown error.
yeah, I don't know exactly what that is.
Markdown.
That might mean something from what I pulled it from. These are just screenshots. First one from the book, and I forget where the second one comes from, honestly. milestone measure for yourself might be, I would hope at this point that people have an answer for 7. 8 might be a little bit more challenging, still working on 8, it's probably okay.
Cutting it in half. 4%.
A lot of these solutions, when you think of them or you see them, they make a lot more sense. But generating that is the key, but that's also what's going to be tested. Is your ability to generate them, not your ability to look at and understand a solution for something. So I want to make sure that people have the time to go through a process before they see a solution. Let's go through some practice problems. There are 2 people in here who witnessed my 350 balloons today.
We talked about.
I said something horribly awkward and immediately noticed it and pointed it out to everybody, which made it significantly more awkward that I noticed it and then pointed it out.
I was in lab with Jimmy for the, I guess it was like first part of your class.
Yeah.
You were on break. You just watched the lecture. Then you brought up I think you brought up compilers in the class.
Yeah.
Yep, no, you will bring it up in every class.
It's all related. For those who weren't there, my blunder yesterday was talking about, someone asked a question about the benefits of the waterfall models. Like, there doesn't seem like there are very many of them. So I was talking about how it's a useful process to guide you from conception to delivery. I was like, wait. I'm talking about software, not a pregnancy. Of course, it makes it way worse when you point it out immediately. Everyone's like, yeah, you probably shouldn't have said that.
I didn't think it was that awkward. I just thought it was really funny, to be honest. Like.
Want to compare other development models.
Yeah, right?
Like, what is DevOps?
I'm actually more of an extreme
Yeah, right.
myself.
Mm-hmm.
What's the goal where you do it as fast as possible to get it in by products?
That's extreme. Bro.
Yeah.
Yeah. Prototyping.
Yeah.
I had 4 children, they're all gone.
I
I'm still building the strongest one.
had to throw out the last one. It wasn't what the client wanted.
Yeah.
get used to people like gender reveal parties. And then the parents will like genuinely crash out when the kid's not. gender
Yeah.
revealed.
I can't imagine. You can't have a kid and then expect it to be a particular gender. You gotta be ready for whatever.
Yeah.
Do your damn best.
Explain that to your client.
Yeah, right.
Software comes out how it's supposed to come out. It's God's design.
Yeah, exactly.
They're not bugs.
They're featured.
You can't determine what I'm gonna deliver you from the beginning, so don't even bother communicating with me. All right, what do we have for 7?
I probably have the most ugly version of it, but I am very confident it's gonna work.
Oh, boy.
So, you have 3 A's,
Mm-hmm.
and you concatenate that with A star closure.
Yep.
So if you need more A's, you just make more A's.
Yeah.
And then you also have 1 B, because B is odd. And then you have a parentheses with 2 B's inside.
I got exactly the same thing.
And then you star closure that. So if you need more odd, you can make more odd.
I think that is a minimal expression.
I have a slightly good,
Yeah, what did you do?
I just did 8 of the 3 positive code. That,
If you do 8 of the 3 positive closure, so if you, yeah, you could do something like A plus. Instead of A star,
yeah,
this would work. This says this has to be done 1 or more times. So this is the equivalent of that. Yeah, if you want to use positive closure on an exam, you may.
or is the constant exponents, okay?
Is the what? Sorry.
I did 8, I literally did 8 to the 3rd. Not A.
Oh, you do A to the 3rd, and then you're saying positive closure of that,
Yeah,
because that will only generate groups of 3.
right.
But if we want to be able to generate 4 or 5 or 7, something that doesn't go into 3, that would be wrong. I like this result. I think that's nice. Yeah.
But I just did the extras.
Something like. Yeah, if this is B asterisk like that with no parentheses. This says that we can repeat this 0 or more times. So we need to have an odd number of B's. If we do this 0 times, we have 2. If we do this 2 times, then we have 4. So we need some way of ensuring that remaining B's after the first one come in pairs to keep it odd. Going from an odd to the next odd to the next odd.
So 1 is on it.
Yes. Yeah, I like that. That's a very good approach. But lots of really good ideas out there, and it's worth talking about them. For the potential mistakes that you might make and why they're not going to work. How about 8? Did people get an answer for 8?
I got a good one, I think, for you. So AA star closure. Or sorry, in parentheses, AA.
AA, yep, start closure.
A or B. And then in parentheses, 2B star closure.
I like this. I think this is the minimal one as well. So I can see how n plus m is odd. It just looks like how are you going to count and figure out how many A's and how many B's and verify that they are odd? In order to make something odd, we have to have an even number of each and 1 more that makes it odd from one or the other. And that is the logical breakdown that I think allows you to see the solution to this problem. And since we know that the A's have to come first and the B's have to come last, where this goes is in the middle of that. So regardless of whether this is an A or a B, you only allow for this to be one or the other. It's in the right place. If it's an A, it attaches itself to these A's. If it's a B, it attaches itself to these B's. Do we agree with that? Do we see how this always produces an odd total number of characters? Yeah,
The plus just means have an A or.
yeah, it's the concept of a union or a logical XOR.
My first attempt at this one was super long.
Yeah, it's funny to think if you, depending on how you break the problem down.
It was like, A is even, B is odd, or B is odd, B is even, A is odd.
Yeah.
So I did every single rule.
Yeah, and you can get a solution that works that way. It's just way more complicated. An approach for A, I don't know if I want to write the rest of these out, given how much time we have. I've got a few minutes. So I guess maybe I should query, where are we? Or do we feel like we have results for 19A, or are we still working on that? Results. All right, let's go over it. This is one I actually see people make mistakes, or a similar one to I see people make mistakes on the homework. What do we have?
B star closure A, followed by B star closure A, followed by B star closure. So you can shove as many B's where language.
It's ABC.
So B star closure A.
Oh, it's ABC.
You got it,
It's ABC.
You're on the right path.
Oh.
You're so slow, B.
You got it right now.
Yeah, so let him go again. Let him go again.
Yeah,
Yeah, it's gonna be the same structure, except for
Yeah.
it's gonna be B
You had it
plus
right.
B or C star closure. In parentheses.
Wow, I had one job.
B or C star closure, yep,
Then an A,
followed by a single A.
and then another B and C star closure, followed by another A, and then another B and C star closure. So I got.
And you said that's exactly two A's.
Yeah.
What do we think?
That's exactly what I got.
Adequately.
I like it. Yeah, B is harder.
I had a question about if I could do like. You know how like, when you get like rocks and stuff, it's like, oh, it's all 3/8 minus.
Mm-hmm.
Can I do like 3 minus?
Unfortunately, yeah.
So for B, we can have the same structure, you just expand it out to 3 A's and replace them with A or A rank D, basically.
You could.
Is that more complicated?
No, I think that works nicely. So you would be able to, you could either write out, here are all the ways to produce exactly 3 A's, exactly 2 A's, exactly 1 A, exactly 0 A's, or you make each one of the A's optional. So yeah, every A here is going to be replaced with A or empty. And then we just need to do it one more time.
Weirdly, I feel like the ones that are written out in plain English are easier for me to do.
That's an interesting thing to discover.
Yeah.
So can we use the star closure of a language in our regular expressions? Like star closure, of an alphabet, sorry.
Yes, as long as you do any single character.
Right, so you just do like a character, the star closure of the whole alphabet. And
Yeah.
the next character.
Yeah.
Could you simplify this with just like B or C, so like B or C, A, B or C to the third?
Yeah, probably, well. Yeah, you could do that to the third. With the extra B or C star at the end,
Yeah.
yeah. And this repeated a specific number of times, yes. We're unfortunately out of time, but for C. The way to analyze this is the hardest one, is just thinking of every possible permutation. So one occurrence of each symbol, there are 6 different ways to permute A and B and C exactly once. So that leads us to absolute disgustingness, a very long regular expression where you have, I actually have it written down here, it's like A or B or C star, A or B or C star, B, A or B or C star, C, A or B or C star, which is one of the ways to get that. You repeat that for each permutation
Well,
6 times.
BCA, CBA.
Yeah,
Yeah.
it's gross. It's absolutely disgusting. So this is the disgusting one I would never throw on an exam.
So which one of these on the scale, what would actually be like the level of?
Yeah.
progression? Which one?
Probably something more like 7, possibly 8 as a challenge problem. I think that exactly 2 A's, no more than 3 A's, all of those are possible, but kind of this is a little bit more of a challenge. This is much more of a challenge. So I like to try to deviate the difficulty of the problems where I can, but certainly not this. But everything else is viable, more likely this or this than this or this, but somewhere on the exam, somewhere there's gonna be a problem that's more difficult than that.
You said it was designed to take 30 minutes. 30.
Probably closer to the whole hour.
The exam on tomorrow.
Yeah.
Yeah.
Yeah, I anticipate in this class, sometimes people run right up against the end point. So the more and faster you know what you're doing, the more it may help you.
It's always a drawing, take me a long time.
Yep. All right. Next class is taking a quiz, so we gotta vacate and make sure that they have the time to start on time.
You say regex or regex?
I say regex, but regular expressions, it should be regex.
Well, yes, it's interchangeable.
Yeah, right. Giraffics.
I've always just called it rejects, because I.
Rejects.
That's fun.
Yeah. That is.
That's how I would shoot.
That's hilarious when they have a few steps in.
See you tomorrow.
See you tomorrow.
Thank you.